Okay, so this is a projectile motion problem that we typically see, and the easy question is, okay, at what angle will we maximize our range? So there's our range, x. So we know that a given velocity, there's an initial velocity, we have a velocity in the x that's initial, we have a velocity in the y that's initial, there's our angle. And so our net velocity in the y direction would be our initial velocity multiplied by, what is that, sine or cosine? Would be sine. And then this over here would be our initial velocity multiplied by cosine. So if we're looking at our equations, we would say in the vertical direction, which is the y direction, we would say that y would equal yo plus voyt plus 1/2 gt squared, g being the acceleration here. And then for our horizontal direction, we would have x is our x is equal to x naught plus vox times t, since there's no acceleration in the y direction. So the question is, at what angle are we going to see the biggest range? Well, we're wanting to maximize the range. That's what we want. We want to maximize range. And for any maximization problem, let's say we end up with a function. I'll put it over here. We end up with a function that looks like this. Okay, that's a parabola. That's a pretty nice function. Well, we want to know what happens right there at the very max. Well, the thing about the maximum here is that the derivative would equal 0, right? The slope right there at that point would equal 0. So then what we care about is we want to know what our range is, but we also want our range in terms of theta, right? So we know at small angles, and I don't know if it's actually a parabola, but at small angles it's going to go this far. At large angles it's going to go this far. And we want to know what is that angle right there that gives us a maximum value. So that means we actually need to turn this into something that has a theta in it. Well, we can do that a couple of different ways. We can put in what our Vox is. So let's change colors here. So our x is equal to xo plus, now Vox back over here is Vo times cosine theta. So Vo cosine theta. But we have to multiply it by t. Now what's t? Well, here that's going to go over to what we have right there. So we have y is equal to yo plus voyt plus 1/2 gt squared. When we pick in or plug in what we have for initial velocity in the y direction, that's going to be y is equal to yo plus voy. Now it's way back over here. Voy is Vo times sine. So Vo times sine theta times t plus 1/2 gt squared. Well, that may not get us a whole lot of places, other than the fact that if we go back to our initial problem, we can say, hey, we can call this yo, make that 0, but way over here y is equal to 0. We can even say that xo is equal to 0. In fact, I'm going to put that in the color that we had been using it with, so xo would equal 0, which means, hey, that stuff goes away. And then over here, we would say that this stuff goes away. So we have 0 is equal to Vo sine theta t plus 1/2 gt squared. Okay. We can actually solve this and say 1/2 gt squared is equal to minus Vo sine theta t. One of the t's goes away. We're left with t is equal to 2 Vo sine theta all over g, because we multiply the 2 across and then divide by g. Okay. Another way to write it would be minus 2 Vo over g sine theta. That's our t. So if we come back over here, that makes our t, that function, so x is equal to Vo cosine theta multiplied by t, which is this stuff over here, minus 2 VOG sine theta. So minus 2 VOG, nope. So I get sine theta over g. And we're left with something that says x is equal to minus 2 VO squared over g cosine theta sine theta. Now, so that means that is a function of x that is related to theta. Okay, minus 2 VO squared g times cosine theta sine theta. And we want to be able to maximize this. So that means our x prime, or a derivative of x of theta, has to be equal to 0. At what theta will that happen? So we got some calculus ahead of us. So let's take a look at x equals minus 2 VO squared g cosine theta sine theta. And basically what we're looking at here is that we have to take the derivative of this. Well, minus 2 VO squared over g, that's going to be a constant, so we don't have to worry about that. We have cosine theta sine theta, so that's a product rule. So we have x is equal to minus 2 VO squared over g. Now, product rule is derivative of the first multiplied by the second, then plus the derivative of the second multiplied by the first. So the derivative of cosine is a negative sine. So negative sine times cosine theta plus, now the derivative of sine is going to be cosine. I messed up there. Okay. Not the cosine. So the derivative of cosine is a negative sine multiplied by sine. Then we have cosine of theta multiplied by the derivative of sine theta, which is cosine theta. So that's going to look like this, minus 2 VO squared over g, and this is x prime now, multiplied by cosine squared theta minus sine squared theta. Okay, well, if we want this to be equal to 0, then this doesn't matter because that is just a constant. So you can think about multiplying g over, dividing by 2, dividing by VO squared. It's still 0 over here. So really what we're looking at is cosine squared theta minus sine squared theta equals 0, or cosine squared theta equals sine squared theta. Okay, and if we're really talking about, I'll put that up there a little bit. If we're really talking about that right there, then you could take the square root of both sides and say that cosine theta is equal to sine theta. Well, the only theta that actually happens with that, or where that happens, is a theta of 45 degrees, or what is it, pi over 4. Pi over 4. That's the only time that sine and cosine actually equal each other. And so that right there is a proof of why 45 degrees, it maximizes the range of a projectile. Above 45, you get something like that. Below 45, you get something like that. So if you have any questions on that, I can let you know, but we're really talking about just some calculus here. Now, do I expect you to do this on the AP test? Probably not. They're going to be sticking mostly with position and velocity functions with time, not with theta. But the whole thing here is called optimization. And that is looking at a derivative equaling 0 because of this idea of where you get a maximum in your function.